So everybody, welcome to this webinar, Unleashing the Power of IFSF. My name is Kees Maus. I'm the project manager from IFSF. And what we want to present in this presentation is how you could benefit from IFSF. It could be that Gonzalo Gomez will join during this presentation, and then he will take over the presentation. Until he does not join, I will do the presentation. So it's about connecting with the International Forecourt Standards Forum. So if you go to the next. What we will be discussing is about the general benefits of using our standards, what kind of IFSF publications we have, what we believe the standards evolution would be, and also about the Open Retailing Standards repository, what kind of simulators we have, and then we have at the end a question and answer session. On the question and answer session, it's the intention that if you have any questions, that you use the chat function of the Zoom, and then at the end, Jason will read the questions, which then will be answered by me, and also an indication where you can go for more information about IFSF. Go to the next page. So what is IFSF? IFSF, that's a forum of the international petroleum retailers with the common objective of harmonization of equipment, interconnectivity and communication standards for use in the petroleum retail business. So it's mainly about interconnectivity and interchangeability. We also have the approach to work with established professional bodies like pump dispensers, manufacturers, trade association, financial institutions, to achieve common standards. Until now, a lot of different standards have been adopted on thousands of forecourts all over the world. For instance, if you look at the ISO 8583 standards on payments, post to host and host to host, and on loyalty, and these are widely used, as well as several XML standards on dispensers, for instance. We go to the next page. And you're wondering, of course, why you should use IFSF standards. And if you use standards, that allows the retailers to treat the devices as a commodity. And the use of the standards effectively allows retailers to treat devices as commodities. And what they can do, they can select the most appropriate ones for their needs. And they can also benefit then of a more simpler installation. And each device to be changed or upgraded independently, that can be done with the standards. And the lifetime maintenance cost then for the forecourt will be reduced. So also if you want to change, for instance, from suppliers, that would make it easier if you're already using the IFSF standards, because then if another supplier also adheres to the standards, they can easier understand what kind of functionality you were already supplying before. What's also an important benefit is that it can save manufacturers time and cost in research and development. The cost of installing, maintaining and upgrading different types of equipment with different standards has proved a costly nightmare for the industry. So if you have all different kind of different equipment with proprietary standards, then it's very difficult to get them talking to each other. And that also will take more time to implement and new functionality. when you use common technology standards, then substantial amounts can be saved by implementing forecourt equipment. And then if you have then different equipment from different suppliers, these can be interchangeable if they are both adhering to the standards. And what they allow also is that development resource can then concentrate on improving the product rather than defining and rebuilding the interfaces if you go, for instance, from one supplier to another supplier. Go to the next page. Here is an overview on where you can use the different IFSF standards. This is an infographic on where we have defined different standards. So how that works is that we have indicated here the different kind of devices, and then in blue you see a number, and that if you would press on those, then you would be directed to the specific standard we have on our IFSF website. So what kind of things we are covering is, for instance, on the forecourt itself, that's about the different dispensers, so the fuel dispensers, also the car wash, the price pull, the tank level gauge. All of these are talking with different controller devices like the side controller and the POS, the card reader and the EPS system, and an environmental monitoring system. On all of these areas we have developed standards from the EPS and the POS. There is the payment and the loyalty piece, which are talking to the different front-end processes, different acquirers. And then in the cloud there is then from those parties and interfacing, for instance, to the loyalty host or engine or to the different issuers. There is also a mobile payment interface standard defined, for instance, in XML, and also we have one on API as a joint standard with Connexus, which is a global standard. Let's go to the next page. Next one. So where can you find all this kind of information? So we have a website called www.ifsf.org. And on this site you can find the overview of the work groups, the standards and the projects we are doing. So what is mainly done by IFSF is that when a standard is developed, then all our members are invited to participate to a specific work group. And in that work group, the standard will be developed and worked out. And then when that's done, it will be publicized. So the existing standards, they are already on the website. Besides that, so the existing ones are on the website, and they are mainly based on XML or on ISO 8583. The new ones we are working on is related to APIs, and the APIs are also partially published on the IFSF website and on the GitLab. That's a joint open retailing site. And if you see here, for instance, what kind of work groups we have is like a joint API work group, and we have an EFT work group, electronic fund transfer. So that's mainly about payments and loyalties and security. Then we have some other joint work groups, and when it says joint, that means a cooperation with Connexus. Connexus is also a standard organization in the US, which we work together closely in these work groups. So these joint work groups, we have, for instance, loyalty, mobile, Pulse EPS, a forecourt work group, a car wash work group, a joint mobile API work group. Yeah, and if you see there on the standards, you see the standards infographic, and we have one for the non-API standards, and we have one for API standards that all can be found on the website. And on projects, you could find some information on internal projects in IFSF, which we have done already, or which ones are in execution phase. Go to the next page. We have also engineering bulletins, administration bulletins, policy procedures and templates. In the engineering bulletins, there are in the past they were published and were indicating technical specialities to be used on top of the standards. In the standards, you see the same again as in the previous page. And in the software, you see, for instance, shop. That is an area where you can buy simulators and test tools, mainly related to the XML versions of dispenser, TLG, price pool. For instance, on hydrogen, we have that also included in a tool on the shop for the dispenser piece. And we are developing that piece of hydrogen additions now also in the API joint forecourt work group. You also have a list of people who are certified with the old way of standards, because we have a self-certification program. And if you're past that program, then you will be listed on the website that you're certified to be compliant with the IFSF standards. On the right side, you see some parties which we work with together. As I already mentioned, Connexus. Nexo is a payment standards organization. We work together also with OCA, the Open Charge Alliance, and also with EV roaming. And there are also some other resources. If we go to the next one. What is open retailing? So there is an open retailing site, and that is a joint collaboration between IFSF and Connexus, and we deliver that's our aim, to deliver a unified global set of standards for site systems and communications. And the link to this site is mentioned there. And if you go there, then you can see a kind of a video, and if you press on these different buttons of car wash, in-store, etc., then you see more details on each of these areas. Go to the next one. Next one. So the first generation of our standards was related to a LON. So most dispensers are all LON-based. And that is defined to be able to support different configurations. So we had decentralized system, multiple POSs are directly connected to the bus. The dispenser and other controller devices themselves provide the management of their information. You can lock or unlock transactions, and it allows for interoperability between different controller devices and increased resilience. The system is using a single forecourt controller. It manages the different communications with the forecourt equipment, with dispensers, outdoor payment, terminals, price signs, displays. And the forecourt controller is able to store the dispenser transactions. If there are multiple points of sales, then they are responsible for dispatching the data between them. And the forecourt device control, the forecourt dispenser controller that is that is used a lot in the US. But the function of forecourt device controller in Europe a lot of times is built in on the point of sale itself as a controlling device. We go to the next one. So after the LON generation, we go to the XML, and on the LON it was also developed to be able to do LON over TCP/IP. So that's a separate piece of standard. But after that, we went to XML, and there's a widespread of TCP/IP, Internet, and XML as a means of transport presented the opportunity to enhance communications using these protocols. And I saw that Gonzalo just joined the meeting. Gonzalo, are you there?
Hi, everyone. As Case mentioned, the widespread of TCP/IP, Internet, and XML as means of transport presented an opportunity to enhance communications. By using XML, we could access information remotely from outside the service stations. Although local site systems remained in LON, as cabling was simpler and more noise immune than Ethernet, new components started to take advantage of TCP/IP. Same as LON had a defined technology stack definition, that was IFSF first standard called Part 101, now Part 102 became the definition of the new technology stack using TCP/IP and XML, and defined how to route LON information over XML, allowing the creation of LON to XML routers. Protocols for site systems connecting to central applications were developed to take advantage of the new stack as a whole. Standards like FDC, EPS, post-to-host, host-to-host, and loyalty were created. All of these protocols are still current and widely used around the world. This brings us to the third generation, REST APIs. REST APIs have become the de facto standard for API development. Aligning with this global trend, IFSF has been working in the new generation of standards based on REST. Representational State Transfer, or REST, is a software architecture style for building scalable web services and more maintainable architecture, and gives a coordinated set of constraints to the design of components in a distributed hypermedia system. Joining forces with Connexus, some of these APIs are published as a global standard, including an API design guideline to be used by all future REST APIs. Examples of implemented REST APIs can be found in this picture. The ones marked in red represent completed APIs, while the ones marked in green indicate that they are under development, several of them in the Joint Standards Initiative together with Connexus. Some of these APIs were developed by IFSF and can be found within the IFSF website. For example, closed-loop APIs were developed by an IFSF workgroup and was successfully implemented by several members. Others are available in the Open Retailing GitLab repository. This Git repository allows everyone to keep track of the updates in a convenient and common way. We will now concentrate on how the Open Retailing repository information is presented. Let's now enter the Open Retailing GitLab repository. If we log into the GitLab repository, we will find that its folders are organized by groups and projects. Main top-level folders include member tools, that are some of the basic tools that are used for API development and standards conformance control. These may include, for example, some programs that check that all the APIs are written consistently according to the guidelines. Public standards include API guidelines and data dictionary that can be accessed by anybody without even having credentials. The standards include approved standards in a private area with restricted access for members only. Proposed standards are the ones ready for approval. Once voted, they will become a standard and will be moved into the standards folder. Work in progress contains most of the information, and this is where different APIs are developed and discussed within the workgroups. These are some examples of the different available APIs. They can be completed APIs, such as the data dictionary, publicly published in the public folder, or ongoing versions, such as the Forecourt API collections, that are currently under discussion in the corresponding workgroups. Most APIs are currently under discussion, so you will find them in the Work in Progress folder. Several guidelines were developed and can be publicly accessed. These include the Open Retailing Design Rules for APIs, which provide the different guidelines for defining RESTful Web Service APIs using OAS 3 and JSON Schema 0.7. These guidelines help to ensure that APIs created by IFSF and Connexus will be compatible and work well together. The resulting standards adhere to common design principles and design methodologies, making them much easier to understand and to maintain. There is also an implementation guide that includes all the transport alternatives. This document focuses on how to use HTTPS transport for RESTful web services to the best advantage, since this can promote interoperability and are very important to be implemented, and also ensure security. Balancing performance requirements should take priority when considering the different implementation alternatives. Some options for this includes HTTPS with Keep Alive, links in response messages, server-sent events, and WebSockets. The main that we are in use right now are maintaining HTTPS and sending server-sent events as responses. Also, security was taken in consideration, and in the implementation guide there is a document to include security. This document describes all the API implementation guidelines to ensure safe and secure API implementations. It helps to ensure that implementations interoperate with minimal development, and we have security considerations, for example, the TLS transport using 1.2 for security transport, certificate management, how to threat models that are implemented for all the APIs, authentication and authorization methods that are included. This includes supported ones: username and password, API key, and OAuth. As part of ensuring consistent implementation of the APIs, having a consistent transfer mechanism, design and security considerations are not enough. Also, a common set of defined objects are fundamental to ensure consistent APIs. For example, a dispenser should not call a fueling position on a way different than what a forecourt device controller will call it. To achieve this, the data dictionary contains the standard data definitions to be used across all the different API schemas. A schema will be used in an API will be promoted to the data dictionary when several APIs need to use the same type of schema or the same object. This ensures that the schemas are used consistently across all APIs. There are different types of data dictionary components, and this includes elements, objects that may contain several elements, and types that are the basis to define objects and elements. Some special types include the base type that are useful to ensure all the other elements. An example would be the ID 4N base type that refers to a numeric ID of 4 digits. Other special types include enums and extensible enums. These enums are used when possible values are fixed, while extensible enums are when possible values are proposed but others can be added. An example for this could be errors. These are created not to reinvent the wheel each time we use a enumerated field, but also be able to add more in the future. The forecourt controller considers different forecourt devices and they represent them through different classes. A device class describes a specific forecourt device and the associated properties and events. For example, we have the DSP is the fuel dispenser, while the fueling point is an FP, it's a sub-device of the DSP. Tank level is a TLG, but then it has tank probes, that would be TP, that's a component for the TLG. Price pole also might include price pole points, that would be, and that price pole point might include inside its segments. So a price pole refers to the controller, while the price pole point would be the actual poles. OPTs, you have outdoor payment terminals, then you have car wash, considered as CW, and the controlling device would be the one that would rule them all. Let's now understand the API repositories and how they are structured. All API repositories have a common structure. The APIs that are the basic API definitions, but these normally require the schema definitions and examples that are located not only in the schemas and example folders, but also there are several ones that are defined in the data dictionary. So we need to join all these to generate a complete API collection. When you compile all this together, you will get a bundle that is a self-contained API definition with no external references. All these files are in an internal format called OIS3 that allows programmers to insert it into their code and generate API servers or clients, all the base source code automatically. This is a very helpful feature, but it requires a tech savvy to understand it. So now we are left with the docs folder for the non-tech savvy. The docs folder comprises of all the API documentation generated for each specific API collection. It includes several folders, but it will enter in only a few. One of the most important is the schema documentation, that is the same API definition file, but now presented for the rest of the world on a nice HTML file. This is a readable version of the API, but still you need to have some basic understanding to be able to interpret its contents. But no API definition can be without its implementation guide, use cases and process flows for application designers to understand how to implement these APIs. Other information no less important includes security documentation, such as a threat model for each API, and some executive summary that must always be included to present the boss to approve the development using these APIs. I'm done with the API repository for now. IFSF has developed a set of simulators and test scripts to test and sometimes to certify different forecourt device communications. This includes depending on the generation of the standard to test. There is an engine that runs LON scripts to test LON devices. These tools are available for dispenser, car wash, price pole, TLG, and the controlling device. To test the dispenser APIs, we created Postman scripts that are also available. Also, there are several forecourt simulators, both for LONs and for APIs. Each one of these are completely different. There's also a controlling device simulator for both LON and for API. And this can be used to test the LON or the REST devices, respectively. IFSF offers all these simulators in both executable and source code for the manufacturers to jumpstart into their developments.
Any questions?
Very quickly, will it be possible to have the PowerPoint presentation or the PDF presentation?
Yes, sir. No problem at all.
And thank you very much for this initial webinar, IFSF webinar, that explains the benefits of IFSF and how it is articulated between the various groups. Well done.
Thanks, Francois. We do have a question from Santosh. The question is, are there any simulators for the loyalty APIs?
Not yet.
Thank you. Is there a way, yeah, if there is no simulator, is there a way we can validate the API, whether it meets the IFSF standards? I understand. I think the one is the documentation, but if there is a tool which validates, is something
right
I was
now,
looking.
right now there's still no tool for loyalty
Got it.
APIs.
Sure.
Tools have been mainly developed for the different devices, not yet
Yeah.
for EPS and loyalty.
Yeah, and the reason for that is also in the old standards between payment and loyalty, there are so many different options which you have to agree between the different parties on how to use the standard, that it was very difficult to develop also a specific simulator to do this. So normally people develop their own, companies develop their own simulators, and that would represent then what they've agreed between the two parties, which options they would use in the interface.
Sure. Makes sense. That's the challenge we see around when we talk about through a lot of clients. The payment gateway is a bit different with everybody, and that's what we were trying to standardize as well.
Yeah.
Thank you.
So thank you all for attending.